Welcome. My name is Hoang and Thinh, and today I'm very excited to answer your questions. I'm applying for the cloud operation analyst position because it's a perfectly match for my skills and career goals. I know this program is designed for fresher, and as an RMIT student majoring in cloud computing and data science, I'm ready to step into the professional environment. Over the past 2 years, I have built a strong hands-on experience with AWS clouds and Python. In my studies, I focus heavily on designing system architectures. For example, I recently developed a hospital operational support system named Medidash. It's one of my projects. This system manages real-time staff and patient flow, which require careful cloud architecture design. I also designed an academic management system called Alert to help lecturers with data reporting. This project taught me how to translate business needs into technical solution. At the same time, work as a web developer at RMIT, now Culture Tech, has taught me how to optimize backend code and maintain system performance. This is a key skill for cloud operations. Finally, my background as a teaching assistant at VUS helped me build communications and leadership skills. I learned how to explain complex concepts clearly. I believe my combination of technical AWS knowledge and soft skill will allow me to coordinate IT projects effectively and manage client relationships. I'm eager to learn and ready to contribute to BigTech. Moving to the second questions about AWS EC2. EC2 is a core service in AWS that allows us to create virtual servers, which we call instances. AWS provides different types of instances because every application has different requirements. There are 5 main categories. First, we have the general purpose instances, such as the T family or the M family. These offer a very good balance of computing power, memory, and networking. They are the standard choice for most medium-sized web servers, development environments, and small databases. The second, they are the compute-optimized instances, like the C family. These instances are equipped for the high-performance processors. They are designed for the application that need heavy processing power, such as multiplayer gaming servers, scientific modeling, or the batch processing jobs. Third, we have the memory optimized instances, like the R family. We use these for tasks that need to load and process massive amounts of data in memory very quickly. A good example is the high performance open source database or real-time big data analytics. The fourth one, they are storage optimized instances, like the I family. These provide extreme fast read and write speeds directly to the local storage. They are the best for huge distributed file system, data warehousing, or NoSQL databases. And finally, the accelerated computing instances use the extra hardware accelerators like GPUs. The P family or the G family fall into this category. We use these for very complex, heavy tasks like machine learning, deep learning models, or 3D graphics processing. As a cloud engineer, using the right instance type is essential. It's not just about getting the best performance, it's also a critical part of course optimization. We must analyze the application's exact CPU and memory needs to choose the most cost-effective instance. This careful selection ensures that the infrastructure is highly available for over-provisioning resource, which align perfect with cloud operation best practice. For the third question, I will explain how to set up CloudFront on AWS Elastic Block Storage or EBS. So this actually a very interesting and slightly tricky technical question. The short answer is that by design, we cannot connect CloudFront directly to an EBS volume. Let me explain why. So EBS is a block storage service based on the reference on AWS documentation. You can think of it like a raw, unformatted hard drive inside a computer. So it must be physically attached to a specific computer instance to function. By itself, an EBS volume does not have a public web address. It cannot communicate over the internet using HTTP or HTTPS protocols. On the other hand, CloudFront is a content delivery network to serve files to users globally in low latency. The CloudFront requires a valid web origin. This origin could be Amazon S3 bucket, an app, application load balancers, or an EC2 instance. However, if a client had a strict requirement to serve file stores specifically on an EBS volume through the CloudFront, I would design a specific architecture to solve this. So here my step to approach the requirement. Step 1, I would create a EC2 instance and attach the EBS volume to it. Step 2, I will log into the EC2 instance, format the EBS volume with a file system, and mount it to a specific directory in the operating system. So step 3, I would install a web server application to the EC2 instance, such as the Nginx or Apache. I would configure this web server to host the files directly from that mounted EBS directory. Now the file can be accessed over the internet via HTTP. Step 4, so I would create a CloudFront distribution. I would set the public IP address or the public domain name of the EC2 name instance as a custom origin for the CloudFront. By using this architecture, the EC2 instance acts as a necessary bridge. CloudFront can securely pull and cache the data from the EBS volume through the web server. This correct, a practical and secure way to handle this requirement on AWS while maintaining a good performance. Moving on, the fourth question, I would like to share how the NAB data engineering webinar contributed to my learning of cloud computing. First of all, this webinar helped me see the strong connections between cloud infrastructure and data engineering. Mr. Wang, the data engineering manager, shared that building a reliable and scalable platform is a core task. So he mentioned that handling millions of daily transactions required highly available system, and because even a tiny error can cause huge problems for thousands of transactions. This perfectly related to my computing studies, where I learned how to design fault-tolerant and high available architectures on AWS. I confirm that mastering cloud services is essential for modern data processing. Secondly, the webinar changed my perspective on daily operations. Mr. Wang highlighted that a big part of the job is monitoring the pipelines and ensuring data quality, not just writing the code. This taught me how that in cloud operations, maintaining system health or checking logs and troubleshooting issues are just as important as initial setup. Another major takeaway was the importance of a growth mindset, and the business thinking. So Mr. Wang advised me not simply focus on the trendy tunes, but to focus on solving the actual business problem for the end users. This related strongly to my old cloud project. So for example, when I built my Medidash hospital project, I learned that I must understand the hospital operational needs first, and before deciding which AWS service to use. So finally, Ms. Anna shared the detail of StackCamp training program for fresher. This gave me a clear view of professional standards and communication skill required in a global enterprise. Overall, the webinar was incredibly inspiring and gave me a very practical roadmap for my cloud career. Finally, I would describe and reflect on my self-directed learning activities. My main goal for this learning journey was to apply AWS compute, storage, and architect concepts to design an automated cloud workflow for a hospital operational system. My final output was a comprehensive YouTube tutorial video. In this video, I explained the system architecture and demonstrated the hands-on AWS implementation. I also wrote an accompanying video script with the technical references formatted strictly in IEEE style. To achieve this, I create a 4-week timeline. In the first week, I researched AWS documentation and designed the system architecture diagram. During the second week, I use an AWS free tier account to execute the practical labs in the AWS Management Console. I successfully provision an Amazon EC2 instance within a VPC securely connected to the Amazon S3 with the data storage, and utilize the AWS Lambda to automate the processing of incoming data. For the final 2 weeks, I used Microsoft Teams to record my screen, edited my video on CapCut, and submitted the Analyst YouTube URL and the script on Canvas. So reflecting on this project, it was highly valuable experience, I think. So I actively sought feedback from a lecturer regarding to the technical accuracy, security configurations, and cloud best practice on my architecture. I also asked my peers for feedback on the clarity, professional approach, and the pacing of my presentation. So this journey not only improved my technical AWS skills, but also taught me how to manage a project from start to finish. I'm confident to these practical skills will allow me to assist a cloud operation analyst.